In this module, we will explore how IT operations, from hardware manufacturing to data storage and processing, contribute to an organization's carbon footprint and affect the environment on a global scale. Every device, from laptops to massive data centers, requires energy to operate, raw materials to produce, and infrastructure to maintain. The demand for computing power continues to rise, leading to higher electricity consumption and greater reliance on non-renewable energy sources. At the same time, electronic waste is accumulating at an alarming rate, creating toxic pollution and resource depletion. Let's take a closer look at how IT impacts the environment and what can be done to reduce its footprint. IT operations influence the environment in many ways, and these impacts can be grouped into four key areas: hardware, software, processes, and practices. Each of these elements plays a significant role in an organization's carbon footprint, affecting energy consumption, resource use, and waste generation. Understanding the environmental impact of these four areas is the first step toward making IT operations more sustainable. Let's discuss them in detail, and we will start with hardware. The production of IT hardware leaves a lasting impact on the environment, beginning with the extraction of raw materials such as metals, rare earth elements, and plastics. Mining these resources consumes vast amounts of energy and releases harmful emissions, contributing to deforestation, soil degradation, and pollution. Once extracted, these materials are processed in factories that rely heavily on energy, often sourced from fossil fuels. This manufacturing stage further increases the carbon footprint of IT hardware, as each component requires precise engineering, assembly, and testing before reaching the market. Beyond production, global transportation plays a major role in environmental impact. Shipping hardware components across continents by truck, ship, or air adds to the growing emissions crisis. The transport sector alone accounts for nearly 3.7% of global greenhouse gas emissions, making logistics a key factor in its environmental burden. From raw material extraction to global distribution, hardware manufacturing is a resource-intensive process. To reduce its impact, the industry must prioritize sustainable sourcing, energy-efficient production, and responsible logistics to move toward a greener future. Computers, servers, and other IT equipment are constantly drawing power, even when they are not actively in use. This continuous energy consumption results in unnecessary waste and increased carbon emissions. As devices age, their efficiency declines, leading to even greater energy demands and higher operating costs. Beyond energy consumption, the improper disposal of outdated hardware creates another significant environmental issue. Discarded electronic devices contribute to the growing problem of e-waste, which often ends up in landfills or is improperly recycled. Toxic materials such as lead, mercury, and cadmium can leach into the environment, contaminating water sources and harming both ecosystems and human health. To address these challenges, organizations must focus on energy-efficient IT practices, which we will discuss later in this course. You can think of power management settings, optimized hardware usage, and responsible e-waste recycling. Let's discuss software. While software itself does not emit greenhouse gases, it plays a crucial role in energy consumption. Every application, from simple office tools to complex artificial intelligence models, runs on hardware that requires power to function. The more demanding the software, the more energy is consumed by the underlying infrastructure. At the heart of this energy demand are data centers, which power nearly all modern digital applications. These massive facilities operate around the clock, storing and processing vast amounts of data. To function efficiently, they require constant energy for computing and cooling systems, making them one of the most energy-intensive aspects of IT operations. Together, software and data centers account for about 7% of global electricity use, a figure that continues to rise as digital services expand. The push toward energy-efficient software design, optimized data processing, and sustainable cloud computing is essential in reducing this impact and moving toward a greener IT landscape. Let's discuss processes such as printing, device management, non-renewable energy sources, timing and location in energy usage, and commuting or workplace practices. Printing may seem like a routine office task, but its environmental footprint is significant. The high demand for paper contributes to deforestation, reducing natural carbon sinks that help absorb greenhouse gases. Additionally, paper production consumes large amounts of water and energy, making excessive printing a hidden but substantial environmental burden. Beyond paper use, printers themselves contribute to waste. Many older models remain powered on even when not in use, needlessly drawing energy and increasing electricity consumption. Over time, outdated or broken printers add to the growing issue of electronic waste, further straining global recycling and disposal efforts. Leaving devices powered on when they are not in use may seem harmless, but it contributes to significant energy waste. In homes alone, idle electronics account for nearly 23% of total electricity consumption, drawing power even when they are not actively being used. This unnecessary energy use leads to higher carbon emissions and increased electricity bills. The problem is even greater in workplaces and data centers, where computers, monitors, and other devices remain on for extended periods without any real need. The burning of coal, petroleum, and natural gas releases massive amounts of carbon dioxide and greenhouse gases, accelerating global warming and climate change. These fossil fuels continue to power much of the world's energy needs, but at a severe environmental cost. Beyond emissions, the extraction of these resources leads to devastating consequences. Mining and drilling disrupt ecosystems, cause deforestation, and contaminate air and water sources. Oil spills, coal mining runoff, and gas leaks contribute to long-term environmental damage that affects both wildlife and human populations. As the demand for energy continues to rise, the need for sustainable alternatives becomes more urgent. The timing and location of energy consumption play a crucial role in determining its environmental impact. During peak demand hours, when electricity usage is at its highest, energy grids often turn to non-renewable sources such as coal and natural gas to meet the increased load. This leads to a spike in carbon emissions and environmental strain. However, in regions with abundant renewable energy, such as solar power in sunny climates or wind energy in coastal areas, there is an opportunity to reduce reliance on fossil fuels. By shifting energy-intensive activities to periods when renewable energy generation is highest, businesses and households can help lower their carbon footprint. Understanding when and where energy is consumed allows for smarter energy management. Commuting to the workplace is one of the biggest contributors to greenhouse gas emissions. Every day, millions of people rely on fossil fuel-powered vehicles to get to work. Cars, buses, and even trains that still run on non-renewable energy sources. With every trip, carbon dioxide and other pollutants are released into the air, worsening air quality and accelerating climate change. The impact grows with the frequency and distance of commutes, making transportation a key factor in an organization's overall environmental footprint. However, research suggests a promising alternative. A study published in the Proceedings of the National Academy indicates that remote workers could reduce their carbon footprint by as much as 54% compared to those who commute daily. By embracing flexible work models, businesses can take an active role in minimizing emissions while offering employees a more sustainable way to work. Next up is practices. Employee habits in the workplace can significantly influence an organization's environmental footprint. Many employees unknowingly contribute to energy waste by leaving computers, monitors, and printers on when they are not in use. This unnecessary power consumption increases carbon emissions and drives up operational costs. And the last area, data storage. Let's take a deeper look at the environmental impact of data storage, starting with data centers. Data centers are at the heart of our digital world, powering everything from cloud services to websites. But their operation comes at a cost, energy consumption. A huge portion of their energy use goes into powering servers, but an even larger chunk, about 45%, is used for cooling. These cooling systems are critical because servers generate a lot of heat, and without proper cooling, they could fail. On top of that, data centers consume significant amounts of water to keep everything at the right temperature, around 980 million cubic meters annually, which is a huge environmental strain. Now, let's talk about the data we store. The rapid growth of internet use and the surge in connected devices have led to an explosion of data. As this data grows, so does the demand for energy to store, process, and transmit it. The larger the volume of data, the higher the energy consumption, and the bigger the carbon footprint of data centers. But not all data is useful. In fact, a lot of it is what we call rot data, redundant, obsolete, or trivial data. This kind of data clutters storage systems, increases costs, and makes data management more complex. It also poses compliance risks and security challenges, as more data requires more resources to protect and monitor effectively. In this interconnected world, managing data efficiently is more important than ever, not just for the sake of productivity, but for the planet as well. And with this, we conclude Module 1.3 Impact of IT Operations on the Environment. Throughout this module, we explored how IT operations contribute to environmental challenges. We examined the impact of hardware, software, processes, practices, and data storage, highlighting how each area affects energy consumption, resource depletion, and carbon emissions. Understanding these impacts is the first step toward change. Now, we shift our focus to solutions. In the next module, we will introduce the Green IT Framework, a structured approach to reducing its environmental footprint and building a more sustainable future. Thank you for your attention, and see you in the next module.